So let's do an example. So our first example is a chi-squared goodness of fit with equal proportions. Employers want to know which days of the week employees are absent in a 5-day work week. Most employers would like to believe that the employees are absent equally during the week. Suppose a random sample of 60 managers were asked on which day of the week they had the highest number of employee absences. The results were distributed on the next slide. For the population of the employees, do the days for the highest number of absences occur with equal frequency during the 5-day work week? Test at a 5% level of significance. All right, that's a scary word problem, but let's break it down. So what I'm looking at is I have 5 days a week that employees work, and managers believe that the employees are absent equally through the week. So it's not skews a lot on Monday and Friday as people would believe. And that's what we're going to test. And we're going to test it at the 5% level of significance. So here's the data that we've been given. So I've been given, I know that Monday is 15, Tuesday is 12, Wednesday is 9, Thursday is 9, and Friday is 15. So for my alternative and my null hypothesis, remember the null always has the equal sign in it. So the null is the proportion of all categories are the same. The alternative is that the proportion of all the categories are not the same. So if I really wanted to key into the 5-day work week, I could say the proportion of all work days during the 5-day period are the same. The alternative would be the proportion of all the work days during the 5-day work week are not the same. So then I could do this by hand to figure out the observed, the expected, but I don't want to do that because it can take some time. So what I want to do though is I want to do this by Minitab. So the first thing that I'm going to do is I'm going to go to Minitab and I'm going to make a column that says days. Let me do this. Let me do work days. Okay. And then the next thing I'm going to do, and if you get confused, you are more than welcome to go into Minitab and put what I have. So what you want to do in Minitab is the first thing is you want to do the observed count of the days. So what I'm going to do is this. I'm going to go here and I'm going to do work days. I'm going to do Monday, Tuesday, Wednesday, Thursday, Friday. And then I'm going to do observed. So for Monday, we observed 15. For Tuesday, 12. For Wednesday, 9. For Thursday, 9. And then for Friday, 15. So then what I do is I go up to stats and I go over to tables and then I go to chi-squared goodness of fit test, one variable, and I click on it. I'm going to do observed counts here. So I press on this button. Let me change that so you don't see everything. So I do observed counts and I click into the box. It gives me the observed. So I click on that and then it wants the category names. So then I'm going to do work days. I'm going to go down to test and I'm going to do equal proportion. So what that does for me is it tells me I want to treat all of these days the same, that they occur in the same amount. So again, I'm going to do observed for here when I do this. And I was careful to call it observed. And the reason they're saying it's observed is I actually have numeric data in there. And then I wanted to put work days as my category name. So when I get the output, I can interpret it. And then equal proportions. I hit OK. And look what it does for me. So it gave me the days of the week, Monday, Tuesday, Wednesday, Thursday, Friday. It gave me the observed counts that I put in correctly, and make sure you put them in correctly because it does matter. The proportions, it was saying that it was 0.2 or 20%. Now, how did we get that? So we want to know that we had 5 days a week. So 100 divided by 5 gives me 20 or 20%. So that's how we looked at those proportions, 20% for each day. The expected. So how did it get the expected? The expected was the total for the observed, which was 60. I see that here. 60 divided by 5, which was my number of categories, gives me 12. If you don't understand this all the way, I'm going to go back and show you where it is. I actually, because I did skip over it, when I did the example by hand, you can see here again, 60 is the sample size divided by 5, which is the number of categories, equals 12. That's how I got that by hand. And here it is. It's the total number of absences divided by the number of categories. But the great thing about Minitab is I didn't have to do any of this by hand. It gave it to me. So if I had to answer, well, what was the expected for Wednesday? It's 12, and Minitab gave it to me. So if I keep going down, it had the chi-squared test. So I had an N of 60, which is my sample size, degrees of freedom. And we haven't really talked about degrees of freedom since for a while, but for chi-squared goodness of fit, degrees of freedom is the number of categories minus 1. So we had 5 categories minus 1 gives us 4. Chi-squared is the test statistic value, and it was 3, and my p-value was 0.558. And another wonderful thing that Minitab does for me, it gives me a picture of the data. So the expected was in orange, and the observed was in blue. Okay, and remember, the expected was going to be the same because our proportions were the same, and it was 12. But as we can see in the blue, for Monday it was 15, then for Tuesday, it was 12. So it's showing you graphically how each category laid out by expected versus observed. And that's a helpful thing to do. You don't need to worry about the contribution of chi-squared. That's a different thing. It helps to show the different parts and how they add up to give you the chi-squared value. I would really just look at this graph and get your data here to help. So if I go back to my results, again, I showed you exactly what we got in Minitab. One slight thing I do want to show you is, so what if I had all this raw data? What if they didn't give me the pretty table? Well, what you have to do then is you need to type it into Minitab. And if you see here, I have it here in days, and I typed in 15 Mondays, 12 Tuesdays, 9 Wednesdays, Thursdays, and Fridays. And so if I scroll down, I'll show you. I keep scrolling down. You're going to see as the data changes, there's Thursday, and then that's how I did it. But I have every value. Why did I do this? Because sometimes you're going to get your data in an Excel file, or you're going to get raw data which hasn't been summarized. Minitab handles it really, really well. So let me show you quickly. I've got days, and it's a raw data. So I go up to stats, I go to tables, and again, I go to chi-square goodness of fit. So from here, I'm going to put, instead of observed, I'm going to put categorical data. So when I hit that, then I go do days. It would not like my work days because it would only think of it, it would only see the 5 names. When I hit days, again, it is all my raw data. Again, I do equal proportions and I hit OK. And look what it did for me. And now I can tell the difference slightly because remember, for when I gave you the raw data, I actually typed out the names. And it gives you that Friday had 15, Monday had 15, Thursday had 9, Tuesday had 12, and Wednesday had 9. Again, my expected values are the same. And then again, it gave me the same. 60 was my sample size. N with a star, remember, means missing data. We don't have any. Degrees of freedom were 4, chi-squared was 3, and p-value was 0.558. And again, it gave me my pretty table. And I was very specific that I typed out the days of the week, and then I left the work days as the initials. What does that tell me? I got the same results with raw data that I did as summarized data. So if I go back and I give you the outputs, they're the exact same. So now we know from this one set of data that could have been given to us summarized or as raw data, I can run this equal proportion test and get the same results. All right, so now that I know I've got the same results, regardless of summarized or raw data, I'm going to go to my conclusion. So from the Minitab results, we can see that the chi-squared value is 3 and the p-value is 0.558. So if I want to conclude my hypothesis, I've got to compare our p-value to our level of significance. We did that with z-test and t-test. So this is very familiar to you. So again, I'm looking at 0.558 is greater than my level of significance. If you're confused, add the zeros. So again, your decimals equal each other. So because 558 is greater than 500, I fail to reject the null. So what does that mean? Oops. So what's that mean? Because, oops, sorry, it keeps jumping on me. Because I failed to reject my null, let's do this. Because we decided to fail to reject the null, that means we found the null hypothesis to be true. So the proportion of all the categories are the same. So how can I conclude that? So I can say at the 5% level of significance, that is sufficient evidence to conclude that the absent days did occur with equal frequencies. And I just found a typo. So let me go show you what I did. This should not be 500. This should be this. Why? Again, because it was that 5% level of significance. So that was bad on my part. So I'm going to type it up here. Remember, 5% is the same as 0.05. Okay, so make sure when you do that, that you watch for these kind of things, because you saw that I just made a typo and it doesn't need to be that way. So again, check yourself. So at the 5% level of significance, there is sufficient evidence to conclude that the absence days do occur with equal frequencies. All right, what does that mean? That really there's nothing going on that's different. So it could be, so what the managers found is Monday occurs the same as Tuesday, Wednesday, Thursday, Friday. Well, remember, our actual data was slightly different, but those slight differences weren't significant. So we can conclude that the proportions of the workday weeks all occur equally for absences.